try this next one. F of -1 is equal to, let's see, where would -1 fall? It wouldn't be in x less than -1. It would be in -1 less than or equal to x. So this would be -8 over -1, or 8. Okay, f of 2, we'll put that out here. F of 2, where would 2 fall? It wouldn't be in the top one. It's not less than -1. It's also not in the interval from -1 to 2, but not including 2. It's in this third one, x greater than or equal to 2. So that would be 2 minus 2 squared, or 2 minus 4, or -2. We want to find the limit as x approaches -1. So we have to do a similar sort of thing. Let's see, from the left, what would the limit as x approaches -1 from the left be? So anything less than -1, so that would be the 5 minus 3x, right? X less than -1, anything less than that, that's from the left. So that would be 5 minus 3 times -1, that would be 8. And then from the right, so that would fall in this middle interval. X is greater than or equal to -1, but still less than 2. But we just need to be a little bit above -1 to see what happens. And that would be -8 over -1, which is in fact 8. Okay, so we want to check. The limit does exist, and it is 8. Okay, so that limit is 8. Limit as x approaches 2. Okay, so the limit as x approaches 2, well, we know its function value is -2. So we want to see, is the limit the same as that function value? And that will tell us these last two answers. Is it continuous? Well, actually, we can answer the first one. We can answer E. Is f of x continuous at x equals 1? The answer is yes, because the limit exists and is equal to 8. Not only does the limit exist, but it is the same as the function value at that point. So f of -1 is 8. So the function value exists, and it's equal to the limit at that point. So this answer is yes. Okay, so is x continuous? Is f of x continuous at x equals 2? Okay, I've run out of room here, so what I'm going to do is I'm going to erase this. Let's keep in mind though that f of 2 is -2. Okay, f of 2 is -2, so I'm going to erase and write that back in. So let's see. The limit as x approaches 2 from the left. Okay, 2 from the left, so that would be things less than 2, so that would fall into this middle interval here, is -8 over 2 or -4. And the limit from the right, what would that be? That would be from things greater than 2, so that would be this one here at the bottom, is equal to 2 minus 2 squared, or -2. Aha! We have a different limit from the left than we do from the right, so that means this does not exist. That limit does not exist. So remember, in order to be continuous, the limit has to exist. So we've, in other words, got a jump here, right? We've got sort of a jump. So it's not continuous at 2. Okay. Because the limit doesn't exist. We have to have that condition. In order for it to be continuous, the limit has to exist. We can't have any jumps. We can't have any asymptotes. That covers, by having the limit exist, that covers that part of it. And then second is we have to have that the function value exists at that point, so we can't have any holes in the graph or asymptotes. And then the last but not least, we have to have that function value is the same at the limit. So we can't have that case where, remember, the graph had a hole in it and the function value was displaced. So this would have a limit existing here and a function value, but they're not the same. Okay, so that's why you need those 3 conditions. Limit exists, function value exists, and that function value and limit are the same. So we're avoiding all of those pitfalls of discontinuity. Okay, let's see if we can do the same thing here. Let's do some analysis. It says determine whether each statement is true or false and explain. So the first one is limit as x approaches 3 of our function. So as x approaches 3, the question is, does the limit exist and is equal to 2? Well, limit as x approaches 3. So we look at the graph, and it is in fact 2. So that one is true. Part B, limit as x approaches 0 is at -1. Okay, limit as x approaches 0 would be here, and it is not -1, okay, because it's limit as x approaches 0 from both sides at the same time. Well, from the left it reaches a different value, and from the right it reaches a separate value. All right, next question asks, limit as x approaches 0 from the right is that -1. So that's this part right here. Okay, as x approaches 0 from the right, is it -1? That is true. Okay. How about as x approaches -2? Is that 2? Okay, so let's take a look at as x approaches -2. So from the left and from the right, is that 2? Yes, it sure is. Okay, the y value it's getting close to is 2, which is right there. Okay, next one. F of -2, is that equal to 4? F of -2. So we're trying to find the point on the graph at x equals 2. Well, we can see there's a hole here at -2 in this part of the graph, but we can see that it's been displaced, been put someplace else, and in fact that function value is 4. So that is true. How about f of 0? What is the function value at 0? F of 0 is at 3. And it's a little hard to see, so I'm going to have to clear this. Hold on. Clear it so that we can then see that value. So we've got true, 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 false, true. True, 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 false, true. So now we want 0 is equal to 3. So here's 0. X is equal to 0 is right at the origin, and the y value, so if I plug in 0, well, let's see, we've got 2 different possibilities here. We've got this one and this one. Well, this one up at the top is a hole, so the f of 0 is in fact not 3. F of 0 is in fact 1. So this is false. F of 0 equals 1. Right, next one. Limit as x approaches 0 from the left, is that equal to 3? The limit as x approaches 0 from the left. So as we approach the y-axis, that is in fact true. Even though there's a hole there, remember, we don't actually have to get there. We just have to get close to it. Okay? We just have to get close to it, and that is true. So now the next question, H says, the limit of f as x approaches -2, is that equal to the function value at -2? So let's see. Where is f of -2? There it is there. F of -2 is 4. And the limit as x approaches -2 is over here. Limit as x approaches -2 is 2. That function value at -2 is 4. So this is false. And if we in fact look at the graph here, we can see that those are not the same. The limit is different from the function value. So we can in fact answer part K based on that answer, because remember what has to happen in order for a function to be continuous at a function value. Limit has to exist, function has to exist there, it has to have a point at that value, and they have to be equal to each other. So f of x is not continuous at -2 since the limit as x approaches -2 is not equal to the function value at -2. And we can see from the graph it's not continuous. It has that displaced point. Okay. How about is f of x continuous at x equals 1? Well, in order for it to be continuous at 1, the limit has to exist, and the function value has to be the same. So at x equals 1. So here's 1. So we want to take a look at this part of the graph and say, does it have a hole at 1, or does it have an asymptote at 1? And the answer is no, it doesn't. So this is true. It is in fact continuous at 1. And finally, is it continuous at 3? Is it continuous at 3? And the answer is no, right? Because here's 3. What happens when x gets to 3? Right, on I we're okay, but right at 3 we've got that little hole. So that would be false, that f of 3 is not defined. Okay, it is continuous at 1 because the limit exists and the function value is equal to that limit. Okay, last but not least, we aren't necessarily always going to be given a graph. We are oftentimes just going to be given a function and asked to state where that function is continuous. Okay? So in other words, we want to find out where are there problems with the function. In other words, division by 0, right, which might cause an asymptote or things like that, okay? Or values, taking square roots of negative numbers. We can't do that. So that's where sort of a function would fall apart. So since we do have a square root, we want to find its domain. So that's the first thing generally when you want to find where a function is continuous, is you want to find its domain. So the domain is all values of x such that 3x plus 12 has to be greater than or equal to 0, right? Because we can't take square roots of negative numbers. So 3x plus 12 cannot be less than 0. So we do a little bit of algebra here. Subtract 12 from both sides. We get 3x is greater than or equal to 0. Or I'm sorry, 12, negative 12. So undo that there. And then divide by 3, and I get x is greater than or equal to negative 4. So as long as we stay to the right of negative 4, we're okay. There are no other problems with this particular function. There are no other things that would cause division by 0 or anything like that. So this is continuous on the interval greater than or equal to negative 4. Okay. So this next one is a rational function. It doesn't have any roots in it, so we don't have to worry about division by 0, but we do have to worry about, we don't have to worry about square roots of negative numbers in this function here, 3 over x squared minus 9x. We don't have to worry about square roots of negative numbers, but we do have to worry about division by 0, right? We've got x minus 9x. So we want to check the domain is all values of x such that x squared minus 9x is not 0, right? We can't divide by 0, so we don't want that to be 0. So let's see, doing a little factoring, we get x times x minus 9 cannot be 0. That means x cannot be 0, and x cannot be 9 in order for that to be true, okay? So as long as we stay away from those two values, this function is okay. So this is continuous for all values of x except x equals 0 and x equals 9. If we were to write this as intervals, this would be everything to the left of 0, but not including 0, and then pick up again after 0, go up to 9, but not including 9, and pick up again after 9, and everything then greater than that. Okay. All right, so that is it. That's all we have about continuity.